Mr. Sudhish and Nair, are you there online? Am I audible to you, sir?
Yeah. Hi, Shani. Yeah. Okay. Can we get started?
So we'll just wait for 2 minutes.
Okay. Yeah.
Good evening, everyone. On behalf of the Department of Computer Science and Engineering, Adi Shankara Institute of Engineering and Technology, I warmly welcome you all to day one of the 6-day ATAL-sponsored online faculty development program on advancements in cloud and edge computing, research and industry perspectives. We begin today's first technical session with a topic that lays the foundation for modern computing infrastructures, Introduction to Cloud. It's my privilege to introduce our first resource person for the day, Mr. Sudhish Nair, Senior Software Maintenance Engineer at Red Hat India Private Limited, with over 12 years of industry experience. He brings with him rich expertise in enterprise cloud technologies and practical insights from industry, which will be highly valuable for all the participants. Sir, we're delighted to have you with us. I kindly invite you to take over the session and enlighten us with your talk on Introduction to Cloud. Thank you, and over to you, sir.
Thank you, Shani, for the warm welcome. Good evening, everyone. And I would like to start by thanking all the dignitaries and coordinators and organizers for providing me with this opportunity. So let's begin the session with a question. So I hope we can make this session as much interactive as possible. So to start with, can everyone tell how many of you have used cloud today? You can use the raise button in your screen to raise your hand if you have used cloud today. Okay, 4 people. Only 4. We have around 84 participants, which I can 4, 5. Okay. Okay, so how many of you have used WhatsApp today or Instagram Reel? Watch Instagram Reel. Or done an UPI transaction. So currently, if you have used any of these technologies, then you are using cloud behind. So all these technologies are currently deployed in cloud. Not just these technologies. Currently, we are conducting this session in a Microsoft Teams meeting. And I think, as you know, that Microsoft Teams meeting is, as a client, is also hosted in Microsoft Azure Cloud in a geographical location near us. And also there's a stat which states that approximately an average human being who interacts with technology of any kind, either using a mobile phone or internet, uses cloud at least 36 times a day. So in that regard, we almost all of us has used at least 36 to 40 times the cloud today. So even we are conducting this meeting over cloud technology. So to start with, before going into what's cloud computing, its infrastructure architect, different deployment models, and service model advanced concept. And we would also be covering the future trends in this technology. Before going into this agenda, I just want to take a few minutes to discuss why exactly are we discussing cloud. So I think our honorary dignitaries has already explained that why they choose cloud and edge technology as a topic for this FDP program. But exactly, I just wanted to share you with few statistics data. Why cloud? Basically, because today, if you ask anybody, the buzzword is AI or ML. If you ask anyone related to IT or computers field, what they are interested in, what they are working on, no one has to say anything outside AI, ML related topics. So to go a little outside this buzzword and choose a FDP topic for cloud computing edge technologies, I would like to really give a applause to the organizer. That's something brilliant thought process. Okay, can anybody guess that how what's the market share of cloud as of 2025? Okay, I'm shared my screen. Are you able to see it? Just confirming.
Yes, sir, we can see it.
Okay, so yeah, can anyone, you can type in chat or unmute and say, give me a guess, random guess, what would be the market share? It's in dollars of cloud computing. Maybe in background, you can ask chat GPT or Google it. Any random guesses? Okay, so basically the cloud computing is estimated to be around 900 billion US dollars market share as of 2025. So basically 900 billion, if you consider it as a GDP of a nation, cloud computing comes as around 15th biggest nation in nominal GDP terms. So it's even richer than some countries like Belgium, Israel, etc. And it's been estimated to cross 1 trillion in the first quarter of 2026 itself. So $1 trillion industry. So you can estimate how big this industry and how big this opportunity is there. And by the year 2054, it's been predicted to cross around 5 trillion US dollars. The cloud computing industry itself. And it's growing at a CAGR of 15 to 21% currently. Just to give a perspective, if you have invested in mutual fund or stock market in India, with one of the fastest growing economics and stock market in the world, you would be getting a returns of around 12 to 13%. But on the contrary, someone who is investing in cloud computing is expected to grow around 15 to 21% rate, the compounded annual growth rate. So it will cross 5 trillion by 2054. So basically, it would be competing with the big five economies like US, China, India, Japan, etc. In next 20 to 30 years, just the market share of the cloud computing. And also currently, although currently the 52% of this cloud computing market share comes from North America, but it's been recognized that Asia Pacific is currently one of the highest growing market for cloud computing as well. So anyone who is working in India and Kerala, so do you know that more in Kochi itself, in Kochi we have lots of cloud networking underwater cables being put here. So one of the major cloud underwater infra center is located in Kochi with this network cables and infra resources. And considering that Asia Pacific is growing fast and China and India being one of the major nations, as part of this Asia Pacific growth wagon, we should expect that lots of our industries would be going to cloud. Just to give you a backstory, when I started with, I'm currently working as a senior software maintenance engineer in cloud native development pillar of Red Hat India Limited. Uh, Red Hat specializes on basically cloud and containerized products and technologies, starting from Linux, RHEL Linux to OpenJDK, to almost all the softwares which you have used in your cloud area. Red Hat almost ships most of them. And it's an open source based company, which means that most of our source code of the products that we ship is open source and free to access for anybody. But I started with Infosys as a Java developer. And when I started as my first project in a healthcare system, it was completely a on-premise data center. Basically, all the applications were hosted in the on-premise servers of the client. But during it's I think around 2014-15 time, when the company had first started planning to move to cloud. Basically, it was during that time the cloud was the buzzword. Basically, currently as AI is now, at that time it was cloud. And almost all industries and all the applications were discussing about should we move to cloud, why should we move to the cloud. Even our applications also, we had created designs, architects around how to move it to cloud and everything. So it's, I think, only been around 10 years since the development of cloud as a mainstream environment or methodology. To give a background, IBM had first introduced the concept of virtualization in 1965. That was the first time when a concept of resource sharing was introduced, where networking details and all those can be shared as part of virtualization. That was in 1965. But AWS, the Amazon Web Service, which was the early mover in the cloud space, they started around 2006. And the most of the cloud orchestra engine like Docker and Kubernetes only started around 2013 and 14. So considering that it's a really nascent industry, only just decade long, and it's almost reaching a $1 trillion and expected to cross 5 trillion in next 20 years. So yeah, you can just imagine the opportunities and everything. When I started, cloud was just an option or a choice, but now it's no more an option. It's a mandate. Which cloud, how to configure in the cloud, all those can be discussed and detailed, but cloud has become a de facto standard for application development and deployment in nowadays world. So when I talk about modern day, so why exactly was cloud introduced? So previously, when a developer used to work with any kind of technology or applications, the developer's concern was only writing the code to make that application work. Whatever is the functional or non-functional requirements, they just have to satisfy that and write a code to implement it, ensuring the performance, reliability, and scalability. They were never concerned about where this application has been deployed and how this has been deployed, how it will scale, how it will be moved. All those infra things were not considered. We used to have system administrators. Then we had operations heads, everything. You used to look after all the infra and operations parts of the thing. But as the development become more and more complex and speed to the market increased, the time that developer had to deliver a product reduced a lot. Previously, there were application coming out only on 6 months to 1 year basis. Now you have app release almost fortnightly. So with such fast process, it was no longer reliable for the developer to just think about the code. They had to think about lots of things. How it will scale, how many users it would be using, where it would be deployed, how it would be deployed, and how it could be managed after post deployment, how it would be maintained. So now it's not just about code. So application development has become far more complicated, and they have to consider the complex environment in which they have been running. So that's when the concept of cloud came back. So whenever there is a talk about cloud, exactly. So what exactly is the cloud? So I think almost everyone would have used cloud storage. You would be knowing that all our data, all the apps which we use in our phone nowadays, the data is now they provide an option to store it in cloud. Even if you see the Google Drive, Gmail, everything, the data is being stored in cloud. So exactly where exactly is this file residing when we say that in the cloud? Any answers? Any? So anyone can tell what exactly is and where exactly is this cloud residing?
From where you purchase the cloud, they the owner maybe AWS or something else.
Yeah.
Which company you buy, then server will hold your data
Okay.
or
So,
programs.
so what exactly that company provides you with?
Depends on user requirement. Right? Suppose you want IAS or PAS or SAS, whatever you want, for which he has to pay and use it.
Okay, yeah, that's good. So basically, when I talk about cloud, basically, so this was one of my, sorry, a recent experience, not just recent, I think last April. So we always, every year, we onboard lots of new team members, and we just have to train them and mentor them. And so as I was mentoring a new team member who is just fresh out of the college, and we were just starting the orientation and everything, what's cloud native department development and what's happening. I was just asking him, what do you know about cloud? What's cloud native development? So when I asked him what's cloud, basically, the answer I got is basically cloud is someone else's computer. I think almost all of you have heard this term. What's cloud? Basically, it's basically someone else's computer. Although it's technically correct, maybe I would say that partially correct. It can be someone else's computer, but in order for a person's computer to become a cloud, it needs to fulfill few criteria, basically. So yeah, to start with, it's correct that for cloud also you need an hardware, infrastructure or a server, which is residing at some location. It can be in a remote location across geography, or it can be a local location, maybe near to you, or even it can be on premise in your industry or company itself. But there needs to be have a physical infrastructure for a cloud to perform. But on top of that, when we talk about cloud, we are not talking about any specific technology here. Cloud is an environment. So cloud is not a technology or a software or anything which is provided by a third-party provider. It's basically an environment where we can deploy our functions or applications and software as a workload. So basically, cloud would be an environment, and cloud computing is the act of running our workload on the cloud. And we use lots of technologies and tools in order to build and achieve this, the act of cloud computing. So we must first understand the difference between these three terms, although in generic terms. We use them in interchangeably, but technologies and tools we use to build and deploy applications in the cloud environments to ensure the act of running those workloads. And how is it different from virtualization? So there is also lots of confusion, like virtualization and cloud are somewhat similar, or some consider them same. As mentioned, virtualization is a technology, but cloud computing is generally a act or a method of performing that act. It's a methodology. So cloud computing is an abstract term where how you design and how you architect, you have lots of flexibility, but you need to just satisfy with criteria. Whereas virtualization is a technology which enables you to share a physical resource with multiple people. So for example, if you have a single hardware server, you can divide them into multiple small resources, virtual infra resources, and share it with multiple people using virtualization. Whereas cloud computing is an environment that uses pools of this virtualized resource, but it should enable these few criteria. One would be ease of use. So cloud, the physical server or the infrastructure which has been provided by the cloud should have the flexibility to ease of use, basically. So anyone who is using AWS or Google Cloud, they would be knowing that you just have to log into a web URL, create an account, and get yourself assigned a cloud instance and use it. As said, you can use different models on how the payment and the cost works. But the second criteria would be reliability. Although it's a virtual resource which is being assigned, we need to ensure that that's reliable across all conditions. And if it's something like that, your app is deployed today, but evening you don't know what happened to that app, then basically that's not a cloud resource. And third would be interoperability. With the cloud, you should be able to interoperate or move that application from one cloud to another, or one architecture to another, or one system to another easily. There should be option for that. And the last, but the most major one would be scalability. So if you know that if you know about Netflix, around in 2010, when Netflix started as a company which would ship DVDs to their customers. So it's basically you can rent a movie on Netflix, but if you rent a movie on Netflix, what they do is that they ship you the DVD to your location. You can watch them. Once you have watched it, you should have to ship it back in a prepaid envelope. They would share your prepaid envelope. You just have to ship it back. So that was the how Netflix began. Then they moved into streaming services. But when they started with the streaming services, everything was hosted in an on-premise environment. But around 2013-14, they took a decision to move almost all their data to public cloud. So during that time, there were lots of talk around this in the industries. How risky is that, and how well can it go, or what can happen with this move, because Netflix had lots of movie and lots of data. So moving this data to a public cloud, at that time, no one was sure how that will turn out. But when the Squid Game, if you have heard about the Squid Game series, one of the most popular series in Netflix, I think till date it's one of the most watched series in any streaming platform. When it was first introduced, there were around estimated 1 crore to 10 crore hits in a few seconds to that particular show. So in order to handle such a big load, if the streaming platform was deployed on an on-premise environment, then it would have collapsed within seconds. I think few of the members few of us who already were there when the first big billion day sale happened in Amazon. Do you remember any one of you? First big billion days when Amazon happened. At that time, I think there were offers like 1 rupees, etc. There were offers of 1 rupees, and so at that time, you may have experienced that there were lots of there were lots of issues with the server being going down and everything. And it's ironic to know that Amazon was the pioneer in cloud computing. AWS was one of the first movers in cloud space, but still, when Amazon launched a big billion sale, their servers crashed. But Netflix was smart enough that when they had to handle such a big load, they were able to do it. The major reason was the movement to public cloud. Okay, so when we talk about public cloud, exactly what is that we are talking about? What's the blueprint of a cloud? So basically, any cloud system that or cloud environment or methodology is created on the basis of two components. As with building any house plans, you need materials and you need a blueprint of the plan, actual how the house would design. So nowadays you have lots of plans. If you have recently built any home, you would be knowing that it's just not the floor design or anything. You would be having 3D diagram, virtual reality of how your house look, interior design plan, piping design plan, electrical plans, lots of plans. Sorry. So similarly, with cloud also, it's made up of two components that we call, one is infra and other would be the architecture. So cloud infrastructure incorporates all materials while the cloud architecture is the blueprint. So what's the infra in cloud term? Basically, all the servers, the networking components, storage, and all the physical things that is used to build the actual server or the storage space is the infra for any cloud systems. So in generic term, in industry, we talk about it as like bare metal systems. So bare metal system is a simple infra system which you don't have anything on top of it. You can configure as you want. So that's the foundation of any cloud infrastructure. Then when we talk about cloud architecture, so architecture is how about the cloud. So basically there are infinite number of permutation and combination on the basis of which a cloud system can be built. There are major models and major services types related to the cloud. But as per the business requirement of the industry where the cloud is deployed, we need to manage how this particular architecture is developed. So, for example, if you are having a healthcare system, so that architecture may be completely different from a website which sells clothes. So both are developing an application, but both needs to be deployed in a cloud environment, but both architecture would be completely different. So even with old architectures before microservices like monolithic and everything, we always used to have 3 different layers like front end, middleware, and back end databases. Even with cloud architecture also, we use these layers. We use virtualization on top of infra to manage all this. But the architecture model depends on which type of cloud we are using. So these are the 4 basic architecture blueprints which can be used: public, private, hybrid, and multi-cloud. Just go one by one. So it's basically like buying a property in your neighborhood. So while buying a property, there are having a house, you have multiple options. The first option would be to rent a apartment in a building. So that's like a public cloud where you are just renting out the infrastructure. That infra is owned by some cloud provider, a third-party vendor, which we call as cloud provider, and we use it as per our requirement. And once we don't have the requirement, we release it. They share the same infra to someone else owns it. So basically, in public clouds, what happens is that the cost and the time to switching and setup would be very fast, considering that you can just create a login ID, you can start getting how much resource you want. You can just tell the configuration, like from T2 micro or EC2 instance, whatever you need. You can just rent it out, start using it, deploy your application, and move forward. And but the actual application or infra is managed by the vendor. So with this, one of the advantage is that scalability. So it's basically cost is as you use kind of model, where how much you use, that much would be the cost. So you have option to scale as per your requirement. So there is lots of orchestrations and automation tool like HPA tools, which help you scale the infra as per your load requirements. So as the, for example, today, now for next 2 weeks, there is a big billion day and have a huge load requirement. I can scale up the servers. But in on-premise time, we used to have 400 to 500 servers created for that purpose. But what happens after the 2 weeks when that load comes down? What will that 400, 500 servers sitting idle do? Just wasting your cost and finance. So with public cloud, that's the advantage. You can scale up and scale down as per your requirement. And second type is private cloud. It's like buying your own house. So private cloud, you are the owner of that particular cloud infrastructure, and you have the complete control and accessibility over that. It will be inside your own firewall. So you can control the access restriction as per your requirement. Obviously, the cost would be higher. And even the time to set up would be also higher, basically. So this can be used when you are using a high security environment like banking, insurance provider, where your data is very critical to you. You don't want to share it in public cloud or anything. So private cloud can be used in such scenarios. And third is hybrid. So hybrid is a combination of private and public cloud. So nowadays, no one just relies on public cloud or private cloud. Any big organization which has their apps or workloads deployed on the cloud use a combination of private and public clouds, which is connected through a network. So private, where the private cloud is used, it's like I have few data or confidential information which I don't want to share anything outside my own infra network. I need it completely under my control. For example, banking details or customer health insurance detail, personal information details. So I can keep those data in the private cloud, and generic websites and web applications related to your app that can be hosted on a public cloud, which can be easily scaled up and scaled down. So basically, private cloud have a separate VPN connection, separate security systems and everything, whereas public cloud would be easily accessible, and depending upon this, your cost can also be managed to a large extent. And fourth one is multi-cloud. So multi-cloud is kind of an expanded version of hybrid cloud, where hybrid cloud is a combination of private and public cloud. In case of multi-cloud can have clouds from different vendors. So it's a system where you have some applications are deployed on AWS, some deployed on Google Cloud, some on Azure, some on public cloud, some on private cloud. Some may be a managed service instance of the cloud, some may be a dedicated service instance. So it can have all those permutation combination. And for multi-cloud, it's not necessary that they are integrated. It can be hosting a completely different application on completely different cloud. So for example, any customer facing application, they may be deploying on a one cloud, maybe internal application, which is only used for internal business purpose, that may be deployed on a different cloud. So next question would be, when we have different types of cloud, what are the different features available and where to choose it? Basically, as I told, public cloud is owned by the provider, whereas private cloud is owned by you. So public cloud is multi-tenant, so there is a issue when it comes to network latency and security, whereas private cloud is single tenant instance, but it will have necessary cost associated with it. Even scalability is also an issue beyond a program, a set value. Then hybrid cloud is a mix and match of both. So depending upon your use case, for example, I am a normal guy, I want to start a web-based or internet-based company. So I won't be setting up a private cloud and investing lots of infra. Maybe around 10 years back, I had to do that. I had to create a server, or maybe you hire a vendor who could do it for me, which was a huge cost. But now I don't have to do that. I just have to log into AWS or Google Cloud or Azure or any cloud platform. I just create an account, and as per my requirement, I can rent it out in public cloud and use it. But if you are a big banking organization or a healthcare insurance organization and everything, you may need a very large infrastructure. So which may include private cloud and public cloud, a combination of multi-cloud and hybrid cloud environments. So next would be a service model. So just going before service model, if anyone has any questions. Any doubts, any inputs or anything?
I have a small doubt, rather comment, that you mentioned the architecture or blueprint different from infrastructure.
Yeah,
right?
Yeah.
But when my understanding is blueprint will be or any plan, maybe civil work or infrastructure, as you said, bridge construction, building constructions, whatever you make a approved copy is a blueprint. It will be it's a traditional style. But when you say blueprint only for the architecture, it's a little bit of confusion rather clarity.
So in computing term, we call it as cloud architecture. So in generic, as you told, in civil area, what we call is blueprint is a plan that we create before creating any kind of civil constructions, like, right?
Yes,
so
right.
any plan that we create and document it and get it approved, that would be the blueprint of that plan. And in cloud environment, when we in generic term, when you go to any industry with the cloud, what we call, there will be designation called cloud architect and cloud architecture design. So basically the job of this particular person is to design the cloud architecture. So that's the term used in IT industries for this purpose. So in civil industry, what we generically normally call as blueprint, while doing the construction, the diagrams and everything. In computer terms, see, it's a like an analogy, like cloud architecture. That's what we call. So these are all abstract terms. It's not real definition. So,
but in general meaning, infrastructure refer to road or rails or extra which are connected to the your factory or connected to your company. That is called infrastructure. That's what my understanding.
So infrastructure is basically whatever resource you need to develop that particular entity, whatever may be the entity. That's the infrastructure you need. So for example, if I have for example, Infosys Mysore campus, if you say the infrastructure of Infosys Mysore campus, they have around 10 to 15 global education center buildings. There are around 3 to 5 technology development center buildings. They have around 4 to 5 food courts. So when you look up the infrastructure of Infosys Mysore, that's what the infrastructure which we developed. So basically, in cloud computing term, what we call as infra would be the physical servers, the storage networks, or the networking components which is there. as a means physically available for creating this cloud. That would be the infra for the cloud.
Okay, thank you, sir.
Any other questions? Okay. We don't have any other questions. Let's continue. Okay. So basically, next topic is service model. So as we discussed about the architecture and types of architecture models, or the main pillars that we have for cloud, like public, private, and there is another way which evolved when the cloud computing system came into picture. So this is called as a service model. So before the introduction of cloud, or during the era of monolithic architecture, if you had to build so for example, to give you an analogy, if I had to build a biryani shop, what I had to do is that I had to buy a land, construct the restaurant, buy all the equipments, hire a chef, buy all the ingredients required, then do the inauguration. Then only after all this background work, then only I can actually start cooking biryani and sell them. So even before starting the selling process of that biryani, I had to invest a lot beforehand in order to get it set up. That was the era of on-premise computing before the arrival of cloud. So basically, it was like capital intensive kind of investment. You had capex, lots of capital invested even before you sell your first biryani. So even once you sell the biryani, if no one likes it, and you go in loss, all the capital investment that you had is on loss basically. But with the invention of cloud computing, they came up with a model called as a service, where all as per your requirement, the required components were provided to you as a service. So there were different levels of services being provided to you. So basically, you could just like building a house, you could either just buy a land and build a house, or you can buy a normal house without any furnishing or interior, or you can also buy a fully furnished house ready to move in. So basically, these are just an analogy to different types of services models available. So these are the three layers of services available. First would be infrastructure as a service, where you would be only sharing your hardware. So the service provider would be only providing you with the infrastructure, which is the hardware. So infra as a service means the hardware components would be provided you as a service, and this would be owned by the vendor, maintained by the vendor. You just use it to build on top of it. So you would be installing your own OS system, if it's containerization or virtualization, whatever it is, you would be doing that. Then on the top of that, you would be building and deploying your applications. So it's basically like you have an hardware on the basis of a operating system, which would execute all the runtimes. Then in order to application specific runtime environment would be there. So for example, if it's a Java, you need a JDK, JRE. If it's a Python, you need a Python libraries, scripts installed for that, and all the related softwares and everything on top of that. Then on top of that, you need the application runtimes or so-called servers, or to execute the applications. So this was IaaS. Then there came a next level, which is platform as a service. So in platform as a service, they would used to ship you the entire platform to you. You just take care of your application. So platform is hardware plus the operating system part. So the platform would be like, for example, if you're buying a laptop with pre-installed Windows or Linux, it's basically they are giving you a platform. This is not as a service, you are buying it, but in case of cloud, you would be renting it out as a platform. You just take care of application. And the next level would be software as a service. So software as a service They would be just shipping you a software. You can direct, if it can be a desktop based software or a web based software, depending upon which type of software is that, you just have to access it and use it. For example, Gmail is a software as a service. Salesforce, if you have used it, that's a software as a service. The Google Docs, these are all software as service implementations that we use. So from the market share point of view, SaaS is the most convenient and is has the highest number of market share, most used one, where the provider manages everything. You just take care about your work, the actual your utility or function that you need to do. You just do that. And but if you need more control, then you should go below to platform or infra level. So as you go higher up the level, you release the control for convenience. So depending upon your architecture, you can pick the service. So nowadays there is a latest one more service which came up, uh, which is called as function as a service. So if you have recently worked with, any of you have worked with any serverless kind of technologies? Any idea about that? What is serverless? Till now, what everything that we talked about are everything servers being deployed on cloud. When we talk about function as a service, we are talking about a serverless kind of service. So when I say that serverless, it's not like there is no server. What it means is that you don't have to worry about the server. You only worry about, so in software of service, your entire software would be shipped to you. Here, the only a function that you need would be shipped. Basically, if you are using a Lambda, anyone use Lambda? You can just raise your hand in the chat if you have used it. Okay. So yeah, so that's an example of function as a service, basically, where it will be triggered on event basis, event-driven functionalities, majorly used by JMS or messaging services like Kafka and other JMS providers. That's that kind of functionality, widely used function as a service. It is trigger, basically it will be triggered on a scheduled event. When so and so event happens, you need to trigger a function, or when a API is called, you need to trigger a function. So that kind of function happens. So all the serverless functions act as an ephemeral functions. So basically there won't be any persistent data anywhere. It will execute what it needs to be executed. It will return the output. Then it would be stateless. So the state of that particular execution won't be maintained anywhere or persisted anywhere. That's basically it's a advanced version of software as a service, but far more comprised, and it's completely works on serverless function. So just to combine everything, when we talk about a cloud landscape, it consists of two things, basically majorly infra and architecture. Infra is the actual resources or the physical resources which is required. Then architecture is the main part where how you create the cloud depends, and it majorly depends upon the types of model you select. It can be public, private, hybrid, or multi-cloud, and what type of services that you use. So as I told, if it's a IA service, you would be managing all the physical layer, and all the software kind of layer would be application, including operating system, would be managed by you. The rest will be managed by the provider. For platform as a service, you would be only managing your application and its data. All other platform would be actually provided to you by the vendor. For SaaS, you don't have to manage anything. Everything would be provided by the vendor itself. For FaaS as well, it's the similar concept, but here it will be providing you with a serverless functions like Lambda. So in real world, This is how the architecture would be, look like. You would be having different layers, starting from physical layer, then there would be abstraction layer, and at the top there would be orchestration layer. But what's mainly it's done, all this everything efforts that's been put is been to ensure that the developer just focus on the actual implementation or the functionality they need to develop, not to worry about how it's managed at the back end and all these boilerplate things. But as you say, cloud computing was introduced for, there's a saying, I think, the cloud computing was introduced for simplicity. So in nowadays also there's a major question you maybe get asked by any new engineer, freshers, or even with the coming of AI, basically. I think every one of you or even I get asked multiple times, at least a week, that what happened to your job because AI is going to take over everything, it's going to do everything. So this kind of buzz was also there when cloud was initially done, especially for the system admins kind of operations kind of guy, because with cloud was managed to automate and simplify everything that uh, uh, the what would the system administrator or a operations guy would do. So this kind of questions used to arise then. Maybe that's why they built something called as Kubernetes. And Kubernetes is something which ensures the job security for all the system administrator and operation guys. Because in theoretical terms, cloud simplifies everything. But as I explained to you, the real world scenario is yeah, so real world scenario is pretty much complex. You need to manage all the systems which is deployed in the cloud, and it's not humanly possible to manage when this system turns so complex that from 10 servers which we used earlier, now there are 1,000, 10,000, maybe even lakhs of servers being run at a time. Even just to start this number of servers, it's not humanly possible. You may have to hire at least uh, 10 engineers for 1,000 servers at least. That's not humanly possible. So with cloud computing, most of the companies or leadership of the companies, 75% of them, they complain mainly the complexity of this cloud computing infrastructure, how they handle this, and the cost wastage due to this complexity is causing major issue for them. So this is how a real world cloud architecture system would look like. So when you log into a Netflix account or a Amazon Prime website, or even Amazon shopping website, in background there would be a complex architecture which maintains all the interaction between each and every functions, and it would be having thousands of servers, data centers located across geographical locations, different kinds of application deployed on different technologies interacting with each other. So in order to manage this in cloud, become really a headache. So for that, we needed to have a cloud management system. That's what something called as cloud orchestration. So in 2013, Docker came up as a containerization platform where anything and everything can be converted into a container and deployed basically on the go to the cloud environment. And in 2014, Kubernetes was published as an open source project. So it was based on Google's in-house project, which they developed for around 10 years before that, around something called Borg or something. Based on that project, Kubernetes was developed, but they provided it as donated it as an open source project. Currently, anyone can access it. And 10 years from now, Kubernetes is considered as the de facto standard for cloud orchestration platform. And there are many other platforms which is built on top of Kubernetes. like OpenShift and different other platforms. But all these are made on top of the Kubernetes standards which has been defined. And in 2015, there was a foundation formed called as Cloud Native Computing Foundation, which is managing and maintaining all these open source projects related to cloud orchestration and DevOps technologies. So when we talk about orchestration, it's not just automation. So in generic term, automation, what does automation means? Automation is a concept of what you call it? It's a concept of removing human intervention from doing a task. So basically, if you have to start a server, normally with a human interaction, you run a command. Human would running opening a terminal, running a command to start a server. When you are saying that I'm automating it, my intention is that that should run without any human assistance. I don't have to run a script or anything in background to achieve the complete automation. But what orchestration is happening is that in this complex environment where we have thousands of functions or workloads interacting with each other, I need to ensure that all these particular systems are interacted and maintained in proper logical orders. So in order to orchestrate the interaction between these individual components, we need a tool which should do that particular. So for example, if the order is first start a server, then deploy a application, then open the traffic for the user, then monitor the CPU usage for those traffics, and depending upon the CPU usage, scale up or scale down the required infrastructure, or in generic term, the number of pods or instances used. So if you want to do all this thing, automating individual tasks won't be enough. You would need a tool which would do this sequentially and ensure that the previous task is successful before doing the other task, and maintain that orchestration. And maybe this particular task may be performed in a different cloud location, and maybe deployed using a different technology so itself. So the cloud should be capable, the tool should be capable of handling all these things. So that's where orchestration came. So in simple terms, if automation is a musician who would be playing violin, flute. So there are, in a song composition, there would be lots of musicians. One would be a singer. There would be lots of drum artists, violin players, guitarists, depending upon the composition. But there need to have a conductor who ensures that everything is played according to the musical note which has been composed by the director. That's the purpose of the conductor, to ensure that everything flows in a specific order so that music comes out perfectly as the director had composed. In this case, the director would be the architect who created this architecture, how he designed or envisioned it. The orchestra needs to be programmed or configured so that it's been executed like that. So orchestration is the conductor here who coordinates everything and ensures everything is executed properly. Okay, so next is manage cloud services. So before going to that, just 2 minutes. Anyone has any questions? Anything to discuss till now? Anyone over here who has a AWS, Google, or Azure account? Anybody logged in using it?
I want to just ask on functional call.
Yeah, function as a service.
Yeah, is it like in Python we will call import TensorFlow as a TF, import pandas as a PD, and import NumPy? These are all functions only. Is it similar to that?
Theoretically and conceptually, yeah, it's similar. So basically, in generic coding term, what we call as a function is a set of code block which is being written to execute a specific output. So basically, it should do only one and only one thing. So it's like single user principle. If you learned about solid principles in coding, that's there's a single user concept. So every function that's written should only do one task. So that's the basic definition of a function. So similarly, when we call it function as a service, even that function which is provided would be doing, should be ideally, not in all real world scenario, it would be doing that, but ideally it should be doing a single task. That task can be anything. So for example, if you are using an edge type of system, so a IoT platform, basically, so in that there would be some broadcasting happening. So for example, in a WhatsApp group, you are sending a message to a group basically. When you are sending a message to an individual, it's a one-to-one communication. But when you're sending a message in a group, it would be a broadcast kind of communication. It's not necessary that all the users in that group would be online at the same time when you're sending it. Some may be logging in after one day, maybe after 5 hours, 6 hours. But the message needs to be seen to them when they access that group. So these all are kind of simple functions which can be triggered on the basis of events. So these are events which is happening when a message is sent, and it can be configured as. So it's not necessary that it function as a service is the only way, but this should be most what you call resource effective way to do it, in the sense you don't have much of a overload basically. You don't have to worry about how everything in the background works. You tell him that broadcast this message. It will broadcast that message to whatever topic you have been subscribed to. And how it does, that's been handled in the backend by the serverless logic which executes it. Anything else? Okay, yeah. As I was discussing, does anyone has AWS, Google, or Azure account? Anybody has ever assigned a EC2 instance, or maybe T2 micro kind of instance? Anything work with cloud? Any application deployed? Okay, so just from computing perspective, do you know means how much resource is required to run a kind of T2 micro instance in a cloud environment? Micro is basically one of the smallest kind of instance which is available in cloud. We have micro, mini, major. So it basically depends upon the number of CPUs available in the instance, or the memory and storage, etc. available in the instance. So micro, you can consider it as one of the smallest available instances. Any idea how much, any random guess, how much resource that use? So just share a fact about that. So basically, the amount of resource used by a T2 micro kind of instance is equivalent to the entire resource used by Apollo 11 mission, the computer system behind that mission. You used to launch the rocket. So basically, the NASA had one of the pioneers who developed computing systems basically for their development purpose. So what was a resource that used by the Apollo mission for the computing purpose? Almost that much resource is used by a T2 micro instances. And yeah, so from that point to this point, so for example, that particular computer instance would be, if you have seen older videos or images in YouTube, that particular server room itself, it's called the actual server room because that computer itself, you could get inside that computer or a server and you can just plug out and plug in the hardware components. It was such a big. Whereas the T2 instance, micro instance is so small and it's basically uh, cost would be around point would be it would be free few cents per hour kind of a costing technology. So that's how much as the cloud computing system has transformed the industry basically from the accessibility point and the cost point. Even just to give you another example, any idea how many videos get uploaded to YouTube per hour basis? Sorry, per second basis? It's been estimated that around every minute there are around 500 hours of content being uploaded to YouTube. So if you're using YouTube streaming platform, not for streaming purpose, not the amount of YouTube video being watched, it's the amount of YouTube content being uploaded every minute. And every day it's estimated that the 82 years of content. So basically, the now amount of content get up and uploaded to YouTube in one day. If you have to watch it, it would take 82 years. So 82 years worth of content is getting uploaded to YouTube every day. Still, when we log into we in web browser, we go to YouTube and access any video, anyone have observed any kind of latency or lag in that, apart from the issue with your own internet? Have you ever observed that you from YouTube and such kind of latency? Just imagine that if YouTube had to create such a huge infra system to handle such huge components or maybe storage capacity for the videos in an on-premise system, which was earlier available, how much it would cost, how much it would cost, how much it would effort would it take, how much human being it would have taken to maintain it. But with the cloud computing, it would have just take even fraction of the cost which is required by the on-premise installation. So that's where the cloud becomes, as I started the session, cloud becomes a mandate nowadays, not a option or a choice. And when we go into cloud services, we already discussed about infrastructure as a service, platform as a service, and software as a service, which is also as an extension called function as a service. Apart from that, she told there is something called as managed cloud services. So there are vendors which do all the manage, even for all this system. For example, if you are using infrastructure as a service or a platform as a service, or you have a hybrid model, in most cases, you may not be, as a company, you may not be having or you may not be having enough investment or enough manpower to hire and maintain the complete cloud service, even with those orchestration tools and everything. So even if you're able to install, maintain and everything, it's a huge effort. So there comes the concept of managed cloud services. What here it does is that the third-party vendors in this kind of scenarios, they manages the entire cloud for you. So it may be a private and dedicated cloud that you own, but it gets managed by the third-party vendor. Or it may be a hybrid cloud with a IaaS system. But in this case also, it would be managed by some other third-party vendor. It can be a cloud provider, it can be orchestration tool provider, or any other third-party companies. what it enables is that the cost for setting it up, one advantage is would be the knowledge. Basically, the person, since they would be handling lots of cloud services, the technology and the personas they have would be far more knowledgeable than the person you would be having this in your company. And second would be obviously the cost related to that. Third would be reliability. So managing this kind of infra network, you don't need to uh, worry about whether the cloud, what happens if the infra goes down, because that's been someone else has provided and agreed a contract to ensure the that it remains up for a specific reliability amount time. So this is the another model which has which is called managed cloud services, which can be availed on top of any of these models. And most of the cloud-based industries normally uses managed cloud services. And next, we would be going in discussing about future about of the cloud computing technologies. So as I just told you, in the first half of 2026, not just the first half, even by the first quarter itself, the market share of cloud computing is expected to hit around $1 trillion. You know that how huge is that, and obviously it's been the almost 2/3 of this market share is controlled by the big three. Okay, any three, guess which are these big threes when it comes to cloud computing? Any idea who is the biggest player in cloud computing industry? Can type it out in chat if you don't want to unmute and speak. Everyone slept off? Okay, I got one ping. AWS, okay. Any other? Okay, I'm not sure if we have an option to add a poll to it. I don't think I have it. So how many of think it's Google, the top player? Just raise your hand. Don't sleep off. This is how I think my manager feels when no one talks in his meeting, in our company's meeting. There are 68 people right now. Only one person had raised the hand saying for Google. For Google, only one. Okay. Okay, 3 for Google, 4. And for AWS, how many? You can just drop your hand and raise again. Your thing AWS. For AWS, 2, 3. And how many of you think Azure? AWS people can drop your hand, and anyone who's thinking Azure. Sure, around 4. Okay. The leading player for cloud computing is AWS. It has around 30+% share, followed by Azure, and Google is at the third place. So, and together these three controls around 60%, 60 to 65% of the market share for cloud computing. Now, when we talk about the future about cloud computing technology, as per the recent research and predictions that been around in the different research industries and panels, it's considered that these 4 pillars is going to be the main, what you call, main components which would be detecting the market share or how the cloud, whose cloud would be in at the top, Although AWS is considered to be the highest from the market share, both Azure and Google has a higher growth rate compared to AWS. So the way they are growing at a faster pace, Google has a huge advantage of data analytics. They have a huge Gemini back system, whereas Azure has a huge advantage of enterprise software system. And obviously, AWS was the first mover in this category. That's why they're still leading. But the growth in future would depend who going to adapt on these four components or technologies going forward. So first would be, as everyone knows, it's AI era right now. Everything is about AI, ML, Gen AI, agentic AI, RAG, everything. So anyone speaking about computer nowadays talks about AI. So are these cloud computing or cloud providers or vendors are how they are able to scale when the workloads which needs to be deployed in the cloud is AI workloads. So anyone would be knowing that AI workload is far more resource intensive compared to the older or normal application workloads. Yeah, when we talk about normal servers, we talk in terms of CPUs, but when we talk about AI workloads, we talk in terms of GPUs, and it has lots of computing resources required. And the complete technology and architecture required for running the AI workload is completely different, basically. So are these cloud providers providing the cloud which is AI native? So when I started, as I told, I worked initially with on-premise, then I had worked also migrating to cloud environment as well. But when we started migrating to cloud environment, what we called was cloud-ready applications, because it was initially developed for on-premise environment. Then we were adapting it to cloud, so it was cloud-ready applications. Now the pillar that I worked in Red Hat, it's called cloud native development. So all the application or tools that we develop is basically cloud native. It's basically natively developed for a cloud environment. But next would be all the application and infra would be AI native. Are they cloud environments which has been provided, are they AI native? That's the next big question. If it's that, then it would be, they would be having huge advantage going forward. And the second pillar is basically edge computing. Maybe even till 3-4 years back, only smart thing we had in our hand was a smartphone, apart from computer. Obviously, the computer system from a huge, large room has been reduced to the size of our palm with smartphones. But even till last 3-4 years, smartphone was the only smart thing which we had in our hand. But in past few years, there has been huge explosion with IoT devices. Although Google Home and Alexa has been around for some time, but nowadays, even you have smart rings, smart watches, even your fridge, mixer grinder, washing machine, everything is, if you go to any sales shop, everything has an AI system embodied it. Everything is been sold as smart systems. When starting with almost all the components, and one of the requirement for smart system is the latency requirement. And obviously, since the smart system is located in a remote location, it cannot always interact with a centralized cloud location. So for example, every request, it will need to send the web request across to the server location, then get do the execution, then revert back the output to the device. That's really costly. So that's when the term or the concept of edge computing term came up, where the concept of localized execution inside those edge devices came up. So nowadays, the edge computing is a thing. Basically, when we are going with automated driving systems, in automation, ADAS features, in more high-level ADAS features in the automobiles, everything. These are our edge devices where the latency is really critical. You cannot have an ADAS system which is communicating with a server at some location and waiting for that output. It needs to have a edge system and a localized inside that device itself to provide that. So in generic term, So any of the here Avengers fans, multiverse or sci-fi movies, if you are watching, you may have heard a lot about time-space continuum. So similarly, today's world is about cloud edge continuum. It's not about cloud or edge. It's about a cloud edge continuum where cloud is the brain and edge would be your reflex. So basically, when you put a hand in your fire, you don't ask brain that you should withdraw your hand. That's a reflex which happens. Similarly, edge in case of cloud edge continuum, cloud would be your brain and edge would be your reflex. So there would be a huge advantage in the and huge market rise in edge computing system. So cloud is the cloud system ready to adapt to those edge capabilities. That would be the second point which needs to be which determines how the cloud goes forward. And the third pillar, and as you, it's a cloud system, everyone is worried about security and everything. You may have also heard about lots of news about lots of celebrities, photos being leaked from iPhone, and lots of data leaks in the recent time. That's a concern even initially when we had when cloud was started. That was one of the major concerns. So with the cloud systems, security becomes a paramount of importance. And any cloud system which adapts to zero trust security feature, which means never trust anything or anyone, and identity first system. So always verify the identity before any transaction or communication. So that's the philosophy on the basis of which the zero trust security is implemented. So cloud which enables or implements this kind of system as a larger advantage. What's an identity first system? So basically, before going into any interaction, you will be providing a token, and once that token is verified, only then interaction proceeds. It's like something in like if you've seen the movie Akere Akere Akere, it's like sadhanam kailundo, and the other person needs to validate it by saying sadhanam kailundu. Unless and until that validation happens, you don't proceed. So it's basically the identity first system also works in similar way. You have a token, that token needs to be verified at both the ends before it validating. You don't trust anybody. And the fourth pillar obviously is cost. With the cloud system, although the cost has been dramatically reduced, especially a common man like me and you can also now go and deploy an application in the cloud without much issues. But still, there is when you're creating a huge amount of architecture, the cloud, as you know that it's as a use of kind of costing model in most cases. So there needs to be a clear planning, and it led to creation of a new field called as FinOps. So basically, previously the financial team had nothing to do with IT, infra development, or actual computing world. But now we have a team which includes finance, architects, developers who would be coming together as FinOps, who would be designing and architecture the entire costing structure of this particular architecture you are going to implement in your cloud. So anyone who excels at implementing FinOps, because all these are pillars were optional till 1 year back, but going forward, these are not going to be optional. These are going to be a mandate if you want to succeed in cloud world. So cloud economics, if anyone wants to advance on it, then only they will be able to excel in cloud system. Although cloud is pay as you use, there will be many of us here who would have taken a gym membership or any subscription, but never used it. You'll just keep on paying that. So as you use kind of system as that kind of a problem. This happened with one of my friend. This is not now, I think around 4 to 5 years back. He had opened a trial account with one of the cloud systems. So basically, it had this much amount of credit was a trial as some kind of offer was running, and they had to. So if you are opening an account, you have to enter your credit card details. and he had entered the credit card details. You never used that account. He created an instance, but never on the first day, but never used it much and forgot about it. About 1 month later, he got a bill of around $400 or something. It was not a huge one, but $400, maybe around 30,000 rupees or something. So he never used anything. He just forgot about it. So that kind of cost may incur if you have an architect, you have created a instance. Maybe there would be a big industry may have created thousands of instances with a huge infra resource. And if you are not optimizing it at the best rate, that bill may be in crores. And those are all waste bills. So FinOps becomes really critical. So these are the major components or which would affect the future of the cloud computing. So as we have covered in this we try to unravel the mystery of the cloud computing. It's not a magic which is residing in somewhere. It's some intelligent engineers who has planned and developed an environment and architect behind it, so that we can create easily reliable, scalable, and interoperable environment for our applications. So this is a summary of what's cloud, basically what's cloud computing, why of cloud computing, and how. Most of these things, as I told, models, there are 3 basic models and 3 service models. Why cloud? Because cost optimization, reliability optimization, and it's more recovery is around 4 times faster than your on-premise environment. And which type of architecture are most majorly used? It's multi-cloud managed services kind of architecture, which mostly used. As I told, the AWS market share is basically currently led by AWS, followed by Azure. And rest of them are rest of and combined is owning the rest, basically IBM Cloud, Oracle Cloud. There are lots of other cloud entities which have specialized utilities. I just want to finish with this question. So basically, with the advance of cloud computing, the main question remains is that who draws this master plan? Basically, since all of you are faculties, you would be the one who would be creating the future engineers. So this would be the question, basically, who would be driving you, basically. One of the engineers that you are creating or mentoring right now, they may be creating the blueprint for our digital future. So I would like to wish you all well. Let me know if you have any questions. That's it from my side. Just another fun fact. If there are lots of ladies over here. Over here, if you are investing in gold, currently the growth rate of silver in the coming years, means even now also, it's far more higher than gold, because most of the components used for servers uses silver. Basically, the chipset and everything uses a lot of silver. And the price of RAMs and GPU server is rising drastically, because most AI workloads, they are just hoarding RAMs and CPU resources. So if you are investing in gold, it's better to invest in silver. That will give better return. Any questions? Multi-billion data center may soon become obsolete. I've not heard about that comment, but obviously, if you are referring to on-premise data centers, yeah, obviously, as we are moving on to cloud-based systems, there is a huge chance that such data centers will become obsolete in future. Since I've not heard that interviewer comment, I'm not sure on basis of what context you were saying that. Anything
Good
else?
evening, dear participants. If you have any more queries, kindly use the next 2 minutes to pose them to the resource person, because we will be starting this next session sharply at 8 p.m. Thank you. I hope there are no more questions.
Thank you, everyone.
So, Mr. Sudhish, thank you very much. On behalf of the Adi Shankara Institute of Engineering and Technology, I express our sincere appreciation for your valuable insights and for such an engaging and interactive session. Thank you very much, sir.
Thank you.